Hello, welcome. Let us discuss about one more type of neural network called LSTM, that is long short term memory. LSTM is a smarter version or an advanced version of RNN, recurrent neural network. We have discussed about the recurrent neural network in the earlier lecture, and this LSTM is designed to remember things for a longer time and forget the unnecessary stuff. LSTM is perfect for tasks where context and sequence over a time really matters, like understanding a long sentence, music, or predicting the stock trends. Let us understand with a real life example. Imagine you are watching a TV series. You remember the key points or a plot twists from the earlier episodes, and you forget the boring or irrelevant scenes automatically. You use that important scenes from the past moments to understand what is happening now. That is exactly what LSTM does. It has built-in memory system to remember important things and forget the remaining things. The LSTM or a long short-term memory came into picture because of limitations of RNN. RNN forgets the long-term dependencies. They are not good at choosing what to remember. But LSTM fixes that problem. It has a gates to decide what to remember and what to forget. Let us understand how LSTM works. Here, the input sequence data enters into the LSTM one step at a time, like words in a sentence. And here is the forget gate, decides which old information to discard. And then the input gate determines what new information to add to the memory. And here memory cell stores the important information over a time, and then output gate decides what information to output. Here is the important thing. Here a forget gate decides what to forget, and here input gate determines what information to add, and here memory stores the important information. These things are missing in RNN. Let us understand some of the differences between RNN and LSTM or a long short term memory. Here RNN cannot remember the long term context, but LSTM can remember the long term context. RNN does not understand what to forget and what to remember, but LSTM understands what to remember and what to forget using the gates that we have shown in the earlier picture. Handling the long sequence. RNN struggles to handle the long sequence, but here LSTM can handle the long sequence of discussions such as chatbots. Early systems were using RNN, later they have moved to LSTM, and subsequently even LSTM is replaced by latest transformer based architecture that we will discuss later. Let us understand some of the real life use cases of LSTM. One is chatbots, which remembers the context for long conversation. Another use case is language translation. LSTM can understand the full sentence structure with grammar. LSTM can also be used for speech recognition, which can convert the continuous speech into accurate text. You can also use LSTM for stock price prediction. Uses a long history of prices to forecast the future trend. You can also use the LSTM for music generation, remembers the melody pattern to compose the coherent music. Now you might have a question whether transformer based architectures can do the same thing. Yes, they can also do the same thing. That is why most of the modern systems like ChatGPT, Google, Gemini, BERT now use the transformer architecture instead of LSTM. So far we have understood what is LSTM, its working mechanism, its real life use cases. Thank you for watching.